Okay. Now, first I'm going to discuss on the topic of water and changes of state. All right. Now, previously in the topic of matter, in lower block P3, P4, you learn about the different properties of matter, right? That matter exists in three states, right? Which is solid, liquid, and gas. And we know that solid has a definite shape and definite volume. And you also learn that liquid has a definite shape but no definite volume. And gas has no definite shape, no definite volume, and can be compressed. Okay, we learned this in the topic of matter. All right. And just now Ivana asked, mentioned about molecules. So this, you can say this as the molecules of gas here, right? But like I mentioned again, the topic of molecule will be, you will learn in secondary school. Primary school, you're not required to know about molecules, atom, and so on. Okay, so you can see here solid, definite shape, definite volume. Okay, liquid, it has definite shape but no definite volume. Okay, but gas, no definite shape, no definite volume. So that's what we learn under the topic of matter. Now, under the topic of heat, okay, we learn about the concept of heat transfer. Okay, what caused matter to become hot or cold? The reason being there is heat. Okay, heat causes matter to become hot or cold. Matter becomes hot when it gains heat, and it becomes cold when it loses heat. Right? Now, in this topic, we are going to look at the different states of water and how water can change its state from one state to another. Now, water, as we know, is a natural resource on Earth and is very precious. All right, about 70% of Earth's surface is covered with water. Okay, as we know, in Singapore, we live in Singapore, water is very, very precious. Okay, we need to save water as much as we can and use, and not to, not to waste water. And water exists in three states. You can see this iceberg, right? So this ice is in solid state. Water here is in liquid state. And gaseous state here, water can exist in gas state also. Now, water exists mostly in liquid state on Earth, river, lakes, seas, as well as the water that we drink and use every day is in the liquid state. Right? You can see the nice picture here of a river. And it can also exist in solid state on Earth. So you can see a picture of an igloo. Okay, igloo in the very cold Arctic regions. Iceberg, snow, and hailstorm are some examples of water in the solid state. And the ice cube that we make inside our drinks are also example of water in the solid state. Now, water can also exist in the gaseous state. Right? So water vapor in the air around us is water in the gaseous state. Now, can we see water vapor around us? Can we see water vapor around us? No, we cannot see water vapor, but we know that water vapor exists. Okay, water vapor exists. So water vapor is, is air or is water in gaseous state. Now, water vapor is air and it is water in gaseous state. Now, steam is another example of water in gaseous state. Okay, steam is another example of water in gaseous state. Now, there is a major misconception. Okay, you can see this kettle and you can see this whitish smoke, right? Now, what do you call this? Talha, since you are chatting a lot, now what do you call this, white smoke that comes out from the kettle? Steam, Okay, is Talha correct? Is that steam? No, Talha. So this is the major misconception that many students face. All right, the smoky substance here is actually called mist, and mist are tiny water droplets. Okay, they are actually in liquid state, not steam. Steam is invincible or colorless. You cannot see steam. Steam is basically water vapor at boiling point. Very hot water vapor, you call it steam. Right? So you can see here on the right side here, the boiling water. So when the water is boiled, okay, it will change state from liquid state to gaseous state, and the steam will be produced. And this steam is invisible, or you cannot see steam. Okay, all right. Now, how does water change in state? When water gains or loses heat, it can change from one state to another. Okay. Now, when water gains heat, the temperature will increase. When it loses heat, the temperature will decrease. But at some point of time, it can change state. Okay. Now, let's take a look at this picture. So, solid ice, when it gains heat, okay, when we put ice on a table, for example, it will gain heat from the surrounding air and it will melt, right? It will melt, it will gain heat and melt, and it changes state to liquid state or water. Likewise, liquid, when it gains heat, when you boil it, it gains heat. After some time, when it reaches the boiling point, it will change to gaseous state or water vapor. Okay? The other way around, if you work backwards, when gas loses heat, it can change state to a liquid state. Likewise, when a liquid it loses heat, it changes state to a solid state. Okay, so you can see here, water can change state, okay, depending on whether it gains or loses heat. Okay, we are going to deal with the process later on. The process is called melting, evaporation, boiling, condensation, melting, evaporation, boiling. Okay, and we will discuss in depth about each of these processes. Now, first, freezing. Ice cubes are formed when we pour water into ice tray and place them into a freezer. So what happens here, when we put into a freezer, water will lose heat, okay, and the temperature will decrease. When the temperature drops to 0 degrees Celsius, okay, the water changes state from liquid to solid state. Okay, from water, it has become ice. So this change in state from liquid to solid is known as freezing. Okay, and the freezing point of water is 0 degrees Celsius. Now take note, this is the freezing point of pure water. It's at 0 degrees Celsius. If the water is not pure, all right, if it's contaminated or if you add some substances, say salt or sugar, the freezing point will not be 0 degrees anymore. Okay. Now next process, melting. So all of you got me? Okay, yeah, good. So melting, when ice cubes are taken out from the freezer and left in a room, they will slowly become liquid again. What we call this? We call this the process of melting. So this happens because the ice cube, which have a temperature lower than 0 degrees Celsius, gain heat from the warmer surrounding and increase in temperature. When this temperature rises to 0 degrees Celsius, the ice cube change state and become liquid. This change in state from solid to liquid is known as melting. 0 degrees Celsius is the melting point of ice. Now let's take a look at this graph. Now let's say that you heat up ice. Okay, initially ice, it is in solid state, right? When you heat up, when you add heat, what happens is that it will start to melt. Okay. Okay, ignore this part. This is Fahrenheit. Okay, at 0, should be 0 degrees Celsius, and boiling is 100 degrees Celsius. Now Fahrenheit is the unit for temperature used in some countries, but not in Singapore. Singapore, Commonwealth country, we use degrees Celsius. In America, they use Fahrenheit. Right? So at 0 degrees Celsius, the ice will melt, okay, and it will change state from from solid state to liquid state and becomes water. And when we add more heat, it will start to increase again, up to 100 degrees Celsius. And up to 100 degrees Celsius, it will start to boil. Okay, when water boils, it will change state again from liquid state to gaseous state. All right? So this is quite a common graph that you see in your exams. So now I can reverse it. I can reverse the process from gas. When I lose heat, when the gas loses heat, it will condense. Okay, and then it will change into water. All right, so water loses heat further up to 0 degrees Celsius. It will start to freeze, and freeze it becomes ice. So you need to take a look at the graph depending if heat is gained or heat is lost. All right, so you need to be sure whether heat gain or heat loss, and and answer the corresponding process. Now boiling, what is boiling? When you place a pot of water over fire, the water becomes hot and boil. Okay? This happens because water gains heat from the fire and the temperature rises. When the temperature rises to 100 degrees Celsius, the water starts to boil vigorously and change state from liquid state to gaseous state. And this gas is called steam. Please remember that you cannot see steam. Steam is invisible. So the change in state from liquid to gas is at 100 degrees Celsius is known as boiling. Now 100 degrees Celsius is the boiling point of water. 100 degrees Celsius is the boiling point of water. Okay. Next, condensation. What is condensation? When water boils, you will see clouds or mist forming above the boiling water. If you place a tray above the boiling water, you will observe water droplets forming on the tray. Now, a glass of cold drink left on the table will soon have water droplets forming on the outer surface of the glass. So you can see here, this can of Coca-Cola, you can see tiny water droplets. Now, what caused these water droplets to form is the process of condensation. Okay. Now, these are examples of water changing from gas to liquid in the process called condensation. Condensation occurs when water vapor loses heat, okay, as it comes in contact with the cooler surface. All right. Now, can anyone tell me where does this water droplets on this can of Coca-Cola comes from? Anyone? From the surface area, from the cold water. Okay, Zahin say that it comes from the cold water. Not true. From the surrounding air. Okay, water vapor in the surrounding. Okay, very good. The water droplets here comes from the water vapor in the surrounding air. Now, water vapor in the surrounding air, why does it change into these water droplets? Because of condensation. Now, why does it condense? Because it comes in contact with the cooler surface of this can of Coca-Cola. Now, for you to see water droplets, you must, okay, the can of Coca-Cola must be cold at the first place. For example, if you just take it out from the refrigerator, okay, if you buy the Coca-Cola, say from the shelf at NTUC, not from the freezer, you will not see water droplets. Okay, now you only see water droplets when you take out the can of Coca-Cola or any can from the refrigerator or from a cold place. Okay, and then the warmer water vapor around the can of Coca-Cola, when it comes in contact with the cooler surface of the can of Coca-Cola, it will lose heat and it will change state from gaseous state to liquid state. Okay, so that is condensation. Right? Now evaporation. Now what is evaporation? Now water can change state to, okay, can change from water vapor even without boiling. All right, without boiling, water can change to water vapor. Now this happens because water gains heat from the surrounding and the temperature increases. Now this gain in heat enables water at the surface to change in state from liquid to gas. So take note here, it is the water at the surface, okay, which changes state. Now this gas is called water vapor, and water evaporates at any temperature below its boiling point and above the melting point. So I took this diagram. You can have, if you look at this diagram, you don't have to know, actually at your level, you don't have to know these tiny particles, molecules, atoms, but it will give you some idea of how evaporation takes place. So here, during evaporation, the more energetic particles, now the top part of the water here, now this is water. Let's imagine this as a puddle of water. Now the higher temperature at the surrounding here, above the water, it will agitate the molecules or the particles of water which is near to the surface. Now, because of this, more energy which the particles of water at the water surface gets, it will evaporate, okay, and leaving the less energetic one behind. Okay, so again, you don't have to know this, but by showing you this diagram, you can better understand how evaporation takes place. Okay. Now think about it. Do clothes dry more quickly on a sunny day or on a cloudy day? Obviously on a sunny day, right? All of you have experience, okay? If you help your parents to hang clothes outside, so you know that in a hot day, okay, the clothes will dry quite fast, especially in Singapore. But if rainy day, then a bit of problem. You may take a few days before your clothes are dry, or sometimes you have to put inside a dryer, okay? Now, next we are going to learn about factors affecting the rate of evaporation. Factors affecting the rate of evaporation. So the rate of evaporation is how fast or slow evaporation takes place. Now, what are the factors affecting the rate of evaporation? So three factors here: for temperature of the surrounding, wind, and exposed surface area of water. Now take note, the keyword here is exposed surface area of water. Many students, they just put exposed surface area, so leaving out water. Later I'll tell you why this is important to add water. Okay. Now let's look at temperature first. Now water evaporates faster if the temperature of the surrounding is higher. So when the surrounding temperature is higher, the water on the surface gains heat faster and changes to water vapor more quickly. Let's take a look at this experiment, container A and container B. Both has 50 milliliters of water in the beginning. Now in container A, the temperature of the surrounding is 40 degrees Celsius. In container B is 25 degrees Celsius. Now in which container will water evaporate faster? Anyone? A, yeah, very good. Because why? The temperature of the surrounding in container A is higher, so the water in container A gains heat faster. Okay, the water in container A gains heat faster than container B, hence the rate of evaporation is higher. Okay, so make sure when you talk about when you are explaining the concept of evaporation, you must include the concept of heat transfer or heat gain, heat gain and heat loss. Right? Evaporation, we're talking about heat gain. Okay, so you must mention that during evaporation, heat is gained. That's why there's a change of state. Right. So next, presence of wind. Now, presence of wind is another factor that affects evaporation. Water evaporates faster when there is wind. We know wind is moving air. Now, the greater the faster the speed of the wind, the greater the rate of evaporation. Water vapor gathers above the water surface during evaporation. Hence, the wind is able to blow the water vapor away, making space for more water vapor to be formed. This increases the rate of evaporation. Right? So the stronger the wind speed, the faster the water vapor is carried away, hence the higher rate of evaporation. So let's take a look at this container, these two bowls of water. Okay, let's say this is bowl A, okay, and this is B. Now, which will evaporate faster and what's the reason? Anyone can tell me which will evaporate faster and explain why? Can anybody explain? Yeah, all of you know that A will evaporate faster, right? Can anyone explain why? Okay, Vamika, you mentioned that the fan is closer, is not enough. okay, you will not score the marks. More wind, so higher rate of evaporation, 0 marks. There's wind to blow above the warm air, okay, 0 marks. Okay, I want to see proper explanation. How do you explain that container A will evaporate faster? Hilma, because the presence of wind is stronger, so higher rate of evaporation. Okay. Now, you mentioned correctly, all of you, most of you mentioned correctly that for in setup A, on bowl container A, the fan is nearer, so hence the rate of evaporation is faster. But why? What is the reason? Why is it that it evaporates faster? So again, you need to mention about, about why is it that, it is able to evaporate faster. Okay, so take a look here. So water gathers water vapor above the water surface during evaporation. So wind is able to blow the water vapor away. Okay, so when the fan is nearer to A than B, so the water, all right, in A, okay, the wind is able to blow the water vapor away in container A greater or more than in container B. All right. So you need to mention that the wind is able to blow the water vapor away in A more than in B. So this increases the rate of evaporation in A. Okay, so you must be able to explain fully. Okay. All right. So next, the third factor affecting the rate of evaporation is exposed surface area of water. Now, water evaporates faster when it is more exposed to the surrounding. The larger exposed surface area of water allows more water to evaporate and thus more water vapor escape from the surrounding, increasing the rate of evaporation. Okay, so the keyword here is exposed surface area of water. So let's say you drop, you accidentally spill water on the floor. So let's say this puddle of water, small puddle of water and a bigger puddle of water. Now, which will evaporate faster? Okay, the water or the puddle of water which has greater exposed surface area here will evaporate faster, right? Because why? It has greater exposed surface area of water. Hence, the rate of evaporation is greater. So if you take a look at this container X, Y, and Z. Okay. Now, even though the volume of the water is the same in all three containers, but the exposed surface area of water in container Y is the greatest, so it evaporates fastest, right? So which will evaporate the least? Anyone? Which container, the water in which container will evaporate the least? In X, excellent. X, the water in container X will evaporate the least. Why? Because the exposed surface area of water in container X is the least. So you can see here, again, opening here is very small, is the least, so it evaporates the least. Okay. Now let's recap. So from solid state to liquid state, gains heat. Okay, the process is called melting at 0 degrees Celsius. Liquid state, when it gains heat at 100 degrees Celsius, it will boil and there's a change of state from liquid to gaseous state. Opposite direction, okay, gaseous state, when it loses heat, it will condense into liquid state. From liquid state, when it loses heat, it will, at 0 degrees Celsius, it will start to freeze from liquid state to solid state. Okay, very simple. So these are the three factors affecting the rate of evaporation. Number one, temperature of the surrounding, presence of wind. Third one is exposed surface area of water. Now, water cycle. Now, let's look at water cycle. Water cycle is also part of your syllabus. Now, what is water cycle? It's a continuous movement of water from the earth to the sky and back to earth again. Okay, this is called water cycle. The water cycle on earth ensures that we have a continuous supply of water. Okay. Now, heat from the sun is very important in the water cycle. It drives the water cycle. Evaporation takes place when water from the ground, rivers, lakes, and sea gains heat from the sun and changes into water vapor. So you can see here the water from the different water bodies, the sea, the river, the lakes, okay? It will evaporate and it will change state into liquid state in the form of clouds. Animal and plants also give out water. Okay? Animals, humans, we give out water through sweating. Okay, and the water vapor rises up to the sky where the temperature drops and it becomes cooler. And condensation occurs when the water vapor loses heat and form water droplets. And these water droplets gather together to form clouds. Okay, so this is another misconception. Many students think that clouds are water vapor. Now, clouds are not water vapor. What clouds are, in fact, many water droplets. Okay, they are gathered together to form clouds. Okay, water vapor is you cannot see water vapor, is colorless. All right, the one that you see clouds, they're actually tiny water droplets. It is made up of many water droplets forming together to form clouds. As more and more water droplets gather to form clouds, they get heavier and it falls as rain. Okay, so the rain falls back into the river, lakes, and the sea, and then the cycle repeats again. In countries like Singapore, tropical country, the water cycle is quite frequent because we have lots of water and lots of sun. But in places like the desert area, very little water bodies, and even though it's very hot, but not enough water to evaporate to form clouds and to form rain. So that's why in places where it is very hot, like the desert, you don't experience a lot of rain. Okay. Now let's recap. Water cycle ensures that living things on Earth have a continuous supply of water needed for survival. And evaporation and condensation are the two important processes in a water cycle. Okay. All right. I'm done here with the topic of water. Now, any questions on the topic of water, class? Gas to ice. Oh, you're saying about gaseous state straight away to ice. Okay. This is in secondary school. You learn in secondary school later on. Solid state can actually, go straight to the gaseous state. Okay, but not at primary school. You learn this. The process is called sublimation. You know dry ice, right? Have you all seen dry ice? Okay, they use it in movies and in concerts. Now, dry ice is a solid state, and it will change directly without going through the liquid state into gaseous state. But this is not in your syllabus. Okay. Now, Zikan asking, is humidity exposed surface area? Now, humidity is different. Now, there are other factors affecting the rate of evaporation, like humidity, temperature of the surrounding. But according to the syllabus, you only need to know three, okay? Which is number one, the temperature of the surrounding. Number two, the exposed surface area. Number three, the presence of wind. There are two other factors, which is the humidity will also affect the rate of evaporation. The other one is temperature of the water itself, okay? So plant give out water too. Hamza said, yes, plant give out water. Just like animals and human, we give out water. Plants give out water through the leaves, through the stomata in a process called transpiration. So through the stomata, it loses water. Now plant takes in water. We know that plants take in water through the roots, and the water that is taken in needs to be given out. So how plants give out water is through the leaves, through the stomata, okay, in the process called transpiration. Okay, any other question? Transpiration is the process in which plants loses water. It is not in your syllabus. It's not in the syllabus. You don't have to learn the word transpiration, but you know that plants give out water through the stomata. The exact term you don't have to know. Okay. If no water cycle, then there will be no rain. All right, no water cycle, there's no rain. In the desert area, there is rain, but very rare. Sometimes once a year, 2 times a year. Reason being, there's not enough water, okay, in the desert to evaporate fast enough and to change into a water cycle. All right, that is why in the desert you get very, very little water. Drought. A drought is a period where there is a prolonged period of no rain. Okay. Yes, sometimes in some countries, because of the changes to the weather, like global warming, the various negative impact on the environment. So this causes changes to the system, the weather system. It becomes haphazard. Yes, in some country there could be droughts, a long period where there's no rain. Now, because of this, lots of crops will be destroyed. Animals will die, and in some countries also, humans, they may not have enough water, okay, and then they may suffer from dehydration, and some may even die. Okay, Jolene asking, what's the difference between melting and evaporating? Now they are very, very different. Okay, let's go back. All right. So melting is the process where a solid state changes to a liquid state. Okay. So this process is called melting. Right? Imagine ice. If you put ice on the table, after some time it will melt, right? So this is called melting. But evaporation is change of state from liquid state to a gaseous state. Okay, so don't be confused. So liquid state change to gaseous state. So for example, if taking the example of ice just now, so if you put ice on the table, it will start to melt. Now after some time, after it has melted into liquid, now if you continue to leave it there, the liquid will disappear, right? Now why the liquid disappear? Because it has evaporated into what? Into water vapor. Okay. All right. Can we move on? Okay. Any other questions? Okay, let's move on. The next topic is quite big, which